Okay, so the final conversation that we're going to have with respect to acids and bases is here. We are going to talk, we've talked about Lewis, Bronsted-Lowry a great deal. Now we're going to talk about Lewis acids and bases, and they're very different in a way, but we're going to see that we can map them back over to Bronsted-Lowry sometimes, all right? So a Lewis acid is actually no longer a proton donor, it's an electron pair acceptor. That's what a Lewis acid is, okay? And a Lewis base is a electron pair donor, all right? So you can see that acids that are Bronsted-Lowry acids also fit fine under the definition of Lewis, right? Because if this is acting as a base, look at this. Here's my base, and a Lewis base donates a pair of electrons. So it's donating a pair of electrons, right? Another way to say that with the Bronsted-Lowry is that it's accepting the hydrogen ion, right? So if you have a Bronsted-Lowry acid, you also have a Lewis acid, okay? And likewise, a base. And likewise, if you have a Bronsted-Lowry acid, here's my Bronsted-Lowry acid, it is accepting a pair of electrons. Here's the pair of electrons that it's accepting, right? So again, Bronsted-Lowry acids and bases are also Lewis acids and bases. However, some Lewis acids and bases are not Bronsted-Lowry acids and bases. Look what I have here. Here, I've got a nucleus which is accepting a pair of electrons. Do you see that? So since this is accepting a pair of electrons, right, there's my pair of electrons it's accepting, this is a Lewis acid, okay? And since this guy over here is donating a pair of electrons, this is a Lewis base. All right, can you see that? Now, this is not accepting this base over here is not accepting a proton, which would be required if it were a Bronsted-Lowry. All right, so this is a legit structure. It's a little bit weird looking, but it's a legit structure, and it's a great example of Lewis acids and Lewis bases.